Hello everyone, welcome to the second part of this tutorial on preparing figures using Adobe Illustrator. In part 1, we went over some of the basic functionalities in Illustrator, going over how to make different shapes and edit them. In this part, we will learn or use some of those tools that we've learned in part 1 and go through an exercise of making a figure or a publishable figure. So here's what we'll go over in part 2. We'll go over what the essential components of a figure. When we say a figure, we're talking about a figure that will show up in a research publication. We will start with an exercise. We'll take some data and try to make a figure using Illustrator. A critical part of all of this is how do we import a graph. There's a lot of graphs obviously in the kind of work that we do. These graphs we often prepare in Excel, and we'll see how to import those graphs from Excel into Illustrator and edit them. And finally, once your figure is ready in Illustrator, there are ways of exporting it in several different formats. So we will go over all of this. And by the end of this tutorial, which will be the end of 2 tutorials in Illustrator, you should be able to make attractive graphics or schematics using Illustrator, and most importantly, convert your research data into a clear and crisp publishable figure. So let's get started. So the basic ideas first. Any figure that you will make for research publications will either be a one-column figure or a double column figure. That doesn't need much more, doesn't need more explanations. But what you need to remember is that one column figures are always 3.25 inches wide and two column figures are always 6.5 inches wide. Now, when I say always, different journals will have different sizes that they give, but in my experience over the past several years, they are only slight modifications of these numbers. And so, not knowing which journal to go into when you're just beginning to make a figure, these are uh, these are good numbers to start with. So this is what I always do. If I want to make a one column figure, I try to fit it in 3.25 inches width, and two columns is 6.5 inches. Okay. So any figure that you make, now this is a one column figure that I showed you on the previous page. There are certain essential components of any research figure. First, that figure must have multiple panels labeled using alphabets. So in this case, we have a panel A, panel B, panel C, and panel D. All of these panels have to be individually uh, captioned below this figure when you finally publish this, and that's why it's very important to have these individually labeled panels. Typically, a figure will have drawings or schematics. These are also made in Illustrator, basically shapes. It could have images. Now, these are the rastered part of the figure. These are pictures taken using a camera of your experimental data and then imported into Illustrator. Invariably, it will have graphs, uh, something like that. And of course, in the top of all of this, there is all of the text that goes in. You'll see there's many places where there's a lot of text has to go in here and here to really explain what's going on. So all of these are essential components of a figure. Not every figure will necessarily have schematics, images, and graphs, but I'm just trying to make a list that's all inclusive. So this particular figure has all of them. So what we'll do now is we'll do an exercise. We'll take some data obtained in our lab and try to make a figure in using Illustrator from that data. What we're going to look at, this is our first exercise of making a figure. We are looking at fluid flow through two paper-based devices. One is a control where this is a certain paper membrane which has a orange colored food colored dye that is dry stored on it, and we are going to rehydrate it using water through a top plastic layer which has a hole, and we will observe how the fluid front flows and where the orange dye ends up. And correspondingly, we have a similar device which has the same layer but it has another paper layer on top of it. And I'm going to still add water from here, and I'm going to observe how the fluid front moves and how the rehydrated orange dye moves. This experiment has been done. We already have the data, and now we want to make a research figure that shows the results of this experiment. So with that background, let's get started. Now, before I go any further, one thing I would like to say is that before you make any figure, let's take this as an example, you should have, before even you put the first line on Illustrator, you should have a very good idea of how the layout of your figure is going to be. So you should know whether you want to make a single column or a double column figure. Within that figure, you should know where roughly your panels lie. because if you don't know that, so what I often do is I will take pen and paper and try to just make boxes to tell me that okay, I'm going to have panel A with this information, panel B with this information, and so on and so forth. And once you have that idea of what you're going to make, you can then actually go to Illustrator. So let's go to Illustrator now. Uh, like last time, I have Illustrator opened already, and I will start with a new file of a new canvas of 8.5 by 11 inch, as I said in the last tutorial that I always do. And what I'm going to do now is I know that I want to make a single column figure. And as I had said last time, that single column figures would always be 3.25 inches wide. So I don't usually do this, but you could start by making a guide rectangle. So you make a rectangle that is 3.25 inches wide. So that's 3.2, and then I'll adjust this to be exactly 3.25 from the transform. So that's that. And then I can pull this down, and I know I have a canvas now that is 3.25 inches wide, and I can make my entire figure inside this. Now I had also commented last time that you could have started with an Illustrator sheet itself that's 3.25 inches wide, but I always like to start with an 8.5 by 11 because it gives me a good idea of how my figure looks on the entire piece of paper. Okay, we can zoom in a little bit and say that this will be the place where we'll be making our figure. Now, one thing I can do with this guide box is that I can go ahead and lock it so that it doesn't come in the way of me making a figure on top of it. So the way to do that, as we had discussed in part 1, is to go under the layer and look at all the objects listed under that layer. There's only one object right now, which is selected here, and you can go ahead and lock that object. As soon as you do that, this object is no longer editable, and you can now make figures on top of this using this as a guide. I don't usually do that, but I'll keep it here for some time. I'll also tell you why it's not necessary. But for now, this is a good starting point. So what we will do now is we have some research data here. If you remember, I had showed you a figure of two different devices. The device in which there's only a single layer of paper is called the control, and the one in which there's two layers of paper is called the test. For each one of those, I have extracted 5 time snaps of fluid flowing through that device, and this was a movie in image J, and from which I have extracted the different snapshots for the control and the test. So let's start by dragging an image into our Illustrator workspace. So let's take one of these images. Okay. Now this is very typical of what will happen is you will the original size of the image will appear really large, and we can easily use the transform function. Now how much do I want to shrink it to? What my plan is for this space, by the way, is that on the left end I want the control devices, and I want the few time snapshots, and on the right hand I want the test devices and a few time snapshots, and this total width is 3.25. So let's say I start with something that's roughly half. So I will go with 1.5 inches. I'll make the width 1.5, and because the height and width was constrained, it automatically gave me this. Okay, so I'll place this here, and similarly I can do this with the other 5. So set this to 1.5, and I can do that with the others. Now when you have multiple images that are exactly the same size, what you can do is you can drag all of them together. So in this case, let's say we have 3, 4 and 5 remaining. I will drag all of them. They all come in right on top of each other. So I'll just zoom out here. Okay, that's how large they appear. I have to ensure that I select all of them, and I can at the same time transform all of them to have a width of 1.5 inch. Okay. But now you have to go back and then move these to their correct places. So what has happened now is my last time point has come here, the one before that is here, and the one before that is here. So I will arrange those as I like them. Okay. Now I'm just doing it manually over here. If you want to be more perfect, you can have a spacer line in between this two and always copy that line below this, so you ensure that the space between the panels is the same, but we won't do that in this tutorial. So this is my control panel, where what I see is fluid entered this piece of paper, and it is moving, and then it is pushing away all the orange food dye to the ends. And correspondingly, I'll take all 5 of my test images, insert them all together. Okay, and let's see if I can select all of them and transform their width to 1.5 inch here. Okay, all of them are done. And now I'll place them in their place beside this. So these are the different time points. You see how the alignment tools uh, in Illustrator are really helpful. They help you snap things in place. Okay, let's do that and roughly move this to the center of this. In fact, as I said, I don't really like this guide box, so I'm going to go ahead and um, unlock it and get rid of it for now. Okay, so I just want to play with things over here. I want some space in between these two columns. Okay, so this is my test, this is my control. Now, one of the most, not most, but a very, very important thing is whenever you import an image, JPEG or any format into Illustrator, it's very important to embed it. The way to embed it is to go to Windows and then click on this thing called links. This is already clicked here, and this links window is appearing here. If it doesn't appear, you can always go under Windows and click on links. Here you can see all of the images that were inserted, and as of now they're not embedded. I want all of them to be embedded, so I select all of these and then I click here and it says embed image. When it's embedded, you'll see this mark next to each of this image. It is basically the same thing as so if you don't embed image and you close Illustrator, the file when you on your computer it will open, it will just have a link to this image, but as soon as you share this Illustrator file with someone else, they won't see any of these figures because the original files are not on their computer. So the next step now, once you have all of your images for your results in, is as much as possible try to have some form of a schematic in a figure that explains to the reader what exactly they're looking at. Now you could easily explain all of what's going on and in the figure caption that you write, but a simple schematic is often really powerful. So for example, in this case, this is a single layered paper device and this is a double layered paper device. So a simple schematic, something that shows, for example, this, where I say that I have a single layer of paper here. Let's make it yellow. Black and then fill it with yellow. Rather, let's make this orange. And I say that as compared to that, on the right side I have the same bottom layer, but I have another piece of paper on top of that, which I can fill with a different color, say gray. Okay, and now you can show sort of a water droplet or a pipette tip or something, but just by placing these simple schematics on top of this, it becomes really clear to the reader what exactly is the difference between this and this. Okay, so let's talk about labeling a little bit. So the first thing is you need you need to label the panels. So we go to text and we write a capital A. So one thing you do with these names of the panels is you always use Arial. This is just some conventions I have used over many years, and I would like to have that sort of signature in all the figures that we make. So I always use Arial bold with a minimum font size of 12 and for labeling the panels. Depending on how large your overall figure is, it could go larger or smaller. You'll get it with experience, or basically just look at a lot of published uh, figures from our lab in the past, or I'll just zoom out and get a feel of this overall page and see whether this is visible. So this is a bold letter that has to be visible even at the most zoomed out level. Okay, I can copy that and give this panel name B, call this B. Okay. All the other labeling text, so let's say I want to label that this is paper material A and this gray is paper material B. So let's do that. Again, I go to the text box. All the text that I otherwise write, let's say paper material 1, is always in Myriad Pro. It's one of the default fonts within Illustrator, so that's Myriad Pro. And you usually try to be around Arial 8 and So by the way, these we had bolded, so you can decide what font and whether it's bold or regular or italic from here. And the regular text will always have a regular and Myriad Pro. So I'll say that this is my paper material 1 here, and on this side I have a paper material 1 at the bottom underneath and paper material 2 on top. Okay. Another rule here is never use any font size that is below 6. 6 is the absolute smallest you should go to, and that too in extreme cases when you have a cramped figure and you're trying to get some small numbers in. But 7 is a minimum. 8 is decent. So most of the labeling I try to do in 8, but again it depends a lot on your figure and whether you have space remaining or not. Okay, so far what I'm showing the reader is that I have two different paper assemblies. My fluid is flowing, and it's doing different things in both cases. In one case it's pushing the die away, in the other it's not. Also, what's very different between these two cases that's not apparent right now is the time or the rate at which this happens. And so that's a very important piece of information I want to tell the reader. So I can put a small timestamp, say t equals 0 seconds. Say right on top of the panel. There's several different ways you can do this. This is for you to decide. Again, I'll go with a bold font here. 8-point bold, I think this is fine. So I can say this is 0 seconds. On every single panel I can put a timestamp. This I will know from when exporting from ImageJ. So I don't really know the numbers. I'm just saying that you could go ahead and do this on all 10 panels. So now you have labeled this. If you want to put like dimensions of this paper, you can have a double arrowhead. So you could draw this line. And last time, okay, so it has to be black in color. And then we talked about how to put arrowheads. So in this case, you'll actually put arrowheads on both sides. Okay. And remember from my part 1, I said that you'll almost always have to reduce the size of these arrowheads because they look too large at their 100% size. Okay. So I can say that that is, say, X centimeter, whatever that is. I don't want bold here. It will be regular. Now I don't want this centimeter to be as large as this text, so I think this can stay in 7 because it's not as important a parameter. And you could do similarly something with a line over here saying that this is the dimension of this part. So that also tells the reader what size the piece of paper is. Okay, so I have my A and B. So what next I want to do now is I want to do some quantitative analysis of the rates at which this fluid front is moving. So what I'm going to do for that is I'm going to essentially measure distance from the center of this to where my fluid front is. And I want to also tell the reader what I'm doing, so or which distance I'm reporting. So again, I did an arrow and I reduced the arrowhead to 50%, and you can actually go ahead and do it on all the images. So it tells the reader exactly what distance you're measuring. Of course, here you'll do the correct alignments and stuff, and so on and so forth. So in the last one, I'll say that my arrow goes all the way till here, all the way till end. And now what I want to do, you can make similar arrows here also. Now I want to quantify, I want to make a graph of time on the x-axis and this distance that the fluid front traverses on the y-axis. If you remember from our tutorial in ImageJ, we saw how to measure distances using ImageJ. So that has already been done, and I have some data available with me. So this brings us to one of the most important parts of this tutorial, which is how to edit graphs in Excel and import them into Illustrator. So what I have in my mind is I want a graph that roughly spans this entire width over here. So something of sort of that shape, which is a sort of a widescreen 16:9 aspect ratio almost is what I'm thinking. So now I go to my Excel sheet, and for the next few minutes we will be within Excel because there'll be many things that we'll have to do here. So not a lot of these numbers are real, so don't trust the numbers, but just see what we are trying to do here. What I have here is time on the x-axis in seconds, and on the y-axis I have distance that is traversed by that fluid front. This one is in the control, so you see here x-axis numbers go from 0 to 110 seconds. Y-axis distance goes from 0 to 4 centimeters. And this is the control and this is the test, and the test goes from 0 to 4 seconds significantly faster in only 17.5 seconds, and that's apparent in this graph. This graph is basically just a generic XY scatter plot that you would make in Excel. There's nothing special about it. But this is not how I want my graph to look in my published figure. I don't want this orange and blue color and the grid lines. I want it to be a crisp graph that shows them, that has the minimum components, that shows how the data, how y is varying with x. That's ultimately the aim of a graph. So this is a routine exercise that I will go through. So first of all, we can get rid of all the grid lines because we don't really like those. So just select them, have a clean background. And of course, this also depends on in some figures you may want the grid lines, but in 99%, if not 100% of all figures I've made, I've never had any grid lines. So as much as possible, if this is the only information you're showing on the graph, don't make the graph colored. Just have it a clear black and black over white graph. Okay, so you can have solid black circles here and filled black circles and make everything else black. If you want to do that, it appears to me that these markers are too small. So first, let me go ahead and make these markers slightly larger. So I can go under marker, options. I think I like that, around 8 sized markers, and I'll do this with this graph also. So these details, getting these details exactly right before importing to Illustrator often takes a lot of time. Okay, now I want to convert these into black and white. So I click on this again and I say that I want the line color to be black. I want the marker to have a solid line which is black in color, and the fill, in this case let's say my fill is also black. Okay, so these are my solid circles, and I'll make these hollow circles. So I can change the line here to black. So the line will change the color of the line. Then you have to change the options under marker. So I want a solid filled marker, but I want it to be filled with white in this case. And then I want, let's see, where's the line? The border, I want solid line that is black in color. Okay. Okay, so this is how I changed my graph. The other thing, one important thing to do here is many cases, now in this case I'm sort of making this data, but in many cases we'll have standard deviations on the y values. So here this is my x and y, and these are some standard deviation numbers that in this case I didn't measure, but I'm just making these numbers up, but we'll often have those, and we'll have to plot these standard deviations on top of this. So let's see how to do that. Again, you double click on your data and you do add chart element, and there is error bars here. Now there'll be several options here. There's of course standard error, percentage, standard deviation. These are some things that Excel will calculate on its own, but I don't want that. I have a set of numbers with me that I want on the error bars. So I can go under more error bars options, and in that again I'm getting all of these options. So it is showing me directions, meaning that do you want the error bar to be on both sides, or do you only want it to be minus, which is under the data point, or over the data point? Do you want caps, which is this line over here? So usually we have both and cap as the option, but this data is not right. What I want here in the error bar is this standard deviation over here. So again, the options here are fixed value, percentage, standard deviation, something that Excel will calculate. As opposed to that, we want to do custom. In custom, we say specify value. Now it is asking me for my positive error value. I click here and say that I want my plus standard deviation, and the negative error value is also the standard deviation. And if I do OK, I'll get these numbers are now being represented on these bars as standard deviations. So we can now do a similar thing with this other thing also. So let's skip that. You get the idea. The other thing I will do before putting this into Illustrator is I'll see that my axes, the numbers make sense. So here, for example, I went to the left of 0. I don't want that. And on the right side, I have data till 110, but this is going to 120. So I don't really want that. I want to make a very efficient use of space. So I want my axis to go from only 0 to 110. So you can change that by, I think, double clicking, let's see, on this axis. Yeah, Excel is one of Excel often, yeah, I think this is under access options. It often takes time to get the right option here. So I want this to go from 0 to 110. Okay. Now it says a major value of 20. I can also change this to 10. So it'll, okay, so it'll show me numbers that differ by 10. Y-axis I am okay with. I could have changed this to 4, but that's fine. We'll go to 4.5. Now, different versions of Excel have their own sort of maybe bugs. Even, for example, this version, if you see carefully, has automatically added some horizontal error bars, and in order to access them, I have to stretch out my Excel sheet or graph and click on those and delete them, because we don't really need those. Okay. Okay, now you have to think about the aspect ratio of this figure. We said we need the graph that looks roughly like that. So that's why I'm stretching it a little bit. And the other thing that I really like is to have tick marks. So right now you see that this is just a plain line. So if you again click on this axis, you will see an option of tick marks. So what I do is I do major type tick marks outside. What that means is, if you see, if you can, you'll have to zoom into this possibly, probably. You'll see these small tick marks being formed, and that they tell you exactly on this axis where that number is. And so we'll try to do that on this axis also. So we'll do major type outside. Okay. Oops. Okay. Let me bring this back to size. And now there's other things you can, there's all the other features. For example, you can put a legend. So let's try to do that. Add chart element legend. Let's say I want a legend at the top. And this is too small, so let me increase this font size a little bit. Let's say I like that. At this point now, I can copy this. Now this water C and water surf is just labels that I had given when I had inserted this data. I can copy using Control C, go into Illustrator and paste my figure. Now something wrong is going to happen, so let's watch out for that. You will, this is the first wrong thing that is happening. There's some, it's saying some font is missing. Let's just neglect that and say okay. In this particular version of Excel that I'm, or the combination of Excel and Illustrator that I'm using, any font that's not Times New Roman is not recognized when I transfer from Excel to Illustrator. So let me go back and go back to the Illustrator sheet and let's convert all our fonts to Times New Roman. So it's just a bug which has been fixed in CS6, I noticed. So this is something you should not have to worry about. But because I'm still using CS5, it continues to be an issue. Okay, so that's Times New Roman, and then let's change that also to Times New Roman. This also you'll have to change to Times New Roman. Okay, all right. With that, I will now copy this and put it into Illustrator. I'll also tell you why we are trying to go through all of these, all of this effort. So let's move this graph here, and then we can. So before we scale this, the reason we try to make graphs in Excel and then import them into Illustrator in this format is that every single element in this graph right now, once you bring it into Excel, is editable. So you can edit every single line, every single element, every single font, and so you can really customize this graph to fit with your figure beautifully. So the very first thing to do is you select your entire graph, and then you go under object, release. So you go under clipping mask and release. Okay. And you do it as many times as you continue to see clipping masks. Sometimes you have to do this multiple times. What happens when you release a clipping mask is that it frees up every single object, and now each object is individually accessible. So first thing that I don't want is I don't want any of these outside borders. So I'll select this, get rid of that. Okay, and as you hover your mouse pointer, you will see different rectangles that exist but you can't really see. So I want to select that and get rid of that. Now I know that there's a rectangle that appears here and rectangle outside, and that's about it. There's no other rectangles. All of what exists now is basically your graph. So now I've selected it and I am trying to scale this down to a size that we would like. Let me redo that. Okay. The other way of doing this is I know that I want to make a 3.25 width figure. So I select the entire thing. Let's see if I do 3.25 here. Yeah, it is constraint height and width, and it gives me a graph that basically spans this. Okay, so let's zoom in here. And now I can copy that and put a panel C over here, which will contain my graph. Okay. Now notice in doing this shrinking, the quality of this is now looking really poor. This is because some of the lines have very high um, thicknesses. So we can easily fix that. You click on this line, it's 2 points. I make it 1 point. It already looks better. Similarly, you go to that line, you make it 1 point. It looks better. I always have my axes be black in color as opposed to gray. Okay. Um, what's cool about this is if you see these tick marks are almost sort of non-existent or non-visible. So I can also select all of my text here and move it a little bit. Then I can select, if I click on a single tick mark, all of these are selected and I can simply drag them and make them larger and change their color to black. Okay. What happened here is that they somehow disconnected. So I'm establishing that connection again. Again, I can move all of these numbers a little bit below, select my tick marks and expand them a little bit and make them black in color. And then the text is also gray in color. We can change the type to black. Text size, as I said, and nothing should be below 6. It should be at least 7. So let's go to 7. Right now these are in Times New Roman because we had them in Times New Roman, but now you can change it to whatever you like. Okay. Oh, let's go back to 7. Similarly here, we'll make them black, Arial, and 7. Okay. Now let me zoom out and see how my graph is looking. Okay, it's pretty clean. A few things that we did not change are over here. This also, the stroke could be made 1 point. Here also the stroke could be made 1 point, and so on and so forth. You could change the font of this text. Okay, change the color. So it gives you an idea that every single, I can move this legend to wherever I want. It's pretty neat. You get complete customization over the graph that you're trying to make. And now just see how this graph, now the error bars are missing here. So this is what we end up with. Of course, we don't have labels now. So always you should put what is on your X and Y axis. So I have time in seconds here. Now I did Arial here, but usually I always do Myriad Pro. As I said, that's the font that I default to whenever I use Illustrator. Myriad Pro and say 8 or 9. Okay. Okay. If I want to write a label this, I can copy this and there's an option to rotate, object, transform, rotate by 90 degrees. So it will rotate this, and now I can say distance in centimeter. So another trick of another way of telling the reader that this distance is in fact what this distance is you can define a variable, say L, or yeah, let's say L, which you say is so what I'm trying to do is a colon. So I'm trying to say that this is L, which is distance in centimeter, and then correspondingly here I can label this to be L. Okay, so now hold on a second there. Okay, let's do that again. So that is L that I'm basically putting over here. So now the reader knows that this L corresponds to this L on the y-axis here. Okay, so that looks like a pretty decent figure with 3 panels, and so that mostly covers all the elements of a figure. There's some more labeling that needs to be done here, but you get the idea. Now, of course, I'm going to save. I haven't saved this in a while, so let me first save my file. So this file has been modified outside. Do you want to continue? Say OK. It should now save this file. It takes some time. Now, what I always do after saving is I do a select all or Control A. Why I'm doing this is that if there are any construction objects or test objects that are accidentally left, then they will appear somewhere else and make when you export this, it will include that also. So when I do this and I see that nothing else is out there, um, I know that I'm ready to export. Now notice the width of this is 3.6, but we said that we want to make 3.25 inches. Because this figure was more or less 3.25, I can just do a slight adjustment here and change my width to 3.25, and because my height and width are constrained, it now makes an exactly 3.25 inch wide image. Okay, and this is the reason why I don't start with the guidelines. And now you can zoom out and see how this figure will appear on an entire piece of paper. Okay, so there's many things here. It often takes you a long time to do all the changes in Excel, but it's worth it because here you can now completely customize and make a very clean graph. Okay, now let's learn that once you have this, how do you export this in different formats. So obviously you have to go under file and export, but there are many options here. So typically I export these images in addition to saving the Illustrator file. I export these as JPEGs. You can do TIFFs or many other formats, but many let's call this test.jpg or test underscore figure.jpg. When I do export, it's going to ask me for many options. So here you can play with these, but the first thing is the color model. I always try to keep RGB. It is rare that someone in a journal will ask for a CMYK color code, but it has happened to me once where they have asked for a CMYK, but mostly it's RGB. So we select this to RGB. This is something you have to be careful about. Let's have all images in RGB because it's highly compatible with analysis in ImageJ if you ever need to do this. Usually quality I keep default at high, which is 6. The most important thing is this, the resolution, the DPI. This is a concept we went over in part 1 of this tutorial. Now the journals will tell you what DPI they want to figure at. So high corresponds to 300, medium is 150. 300 DPI is usually what people will ask, and so we'll keep it at 300. But if you want to go any higher, you have to go under custom and then you can set it to whatever you want. So let's keep it at high. And I say OK, and then it should save this figure, test underscore figure here, and I can open this and then this opens. So this is a self-contained sort of figure at 300 DPI. So you can always export it at different dots per inch depending on what the journal is asking for. Okay, I think that we went through an entire procedure for making figures. What's very important to remember is to always embed your images. Now you don't have to embed this because it's all vector graphics, but the images must all be embedded. Okay, so let's see where we are. I think we went over the essential components of a figure. We went over the exercise of making a figure, how to import a graph, and exporting final figure in an appropriate format. Some other formats here, by the way, you can export this in several other vector formats. So you can export them in things like EPS. Let's see if there's EPS around. Actually not, you can't. I thought we could do an EPS, but DWG is an AutoCAD drawing. Never mind. There is a way to convert this into an EPS, but you probably need a separate plugin for that. Okay. So I think we've covered all of these topics, and let's go over what we were planning to learn. And I think by now you must have learned how to make attractive graphics and schematics, and also now you know you've gone through one exercise of how to convert your existing research data into a publishable figure. With that, that brings us to the end of this second part and to the end of this entire tutorial in Illustrator, and I will end this tutorial here.